So, so this morning I'm going to take some time and we're going to talk about vacuum and VMS and what we have out there and some things that were found. And even though we had Doug do a great presentation on Monday about vacuum and how we order it, I will cover some of that refresher. But what I wanted to look at was we know that in conventional milking, vacuum fluctuation can cause problems and mastitis. And we investigated to see how large and centralized vacuum systems could impact that vacuum stability, and could we make it as good as or as good as CMS. So we're going to look at why it's important. We're going to cover some existing installations, and then just because I know it's always easy to say yes, we can do that, even if the answer is no. The reason why we're saying no, so you can explain that to customers better. The vacuum guidelines, some CPT, and then the results of what we found when we've implemented this. So existing, there is actually no automatic milking regulation on. It's all based off of conventional. I know that at the moment the ASABE is currently looking at that, but basically what we have right now is CMS stuff. So the vacuum definition is that, and I'm reading the slide here, is that the regulation system shall keep the working vacuum between 2 kPa or 0.6 inches of mercury. And it should be tested at startup and at different times. Then that is defined at the receiver vacuum. Then the regulation sensitivity, so right at the sense point, that should be within 1 kPa. So either at the regulator or the sense of the VSD, we should be able to not exceed 1 kPa of fluctuation. And then the other part of this is the vacuum pump and where it should be located. The vacuum drop should not I'm sorry here. I'm sorry, there are a few technical issues. It's the first time I've used this. So regulation sensitivity, we did that. Then the vacuum design, you should not have more than a recommended drop of 0.6 inches of mercury from the receiver or the sense point back to the vacuum pump. So we need to keep the distances short. So just to refresh you on that, this is pretty important. So that vacuum receiver should not fluctuate for more than 0.6. That the fluctuation at the sensor should not fluctuate more than 0.3, and the receiver vacuum will follow the room loop in a correctly designed system. And why does it really matter, right? That's what really matters to the customer. So the VMS was originally designed as a single and individual vacuum system, and it works well when you have smaller herds that use 1 or 2 VMS for farms. But no, many farms in the US don't fit that. So people were looking and built individual vacuum systems. Now, it's not new. Mason-Dixon Farms has been running this for 15, 16 years. But we do know that these have some pretty big limitations. But in my opinion, we need to make sure that a multiple VMS single vacuum system, it should work as good as an individual vacuum system per VMS. So I know this is a lot of technical data, but when we look at how a VMS operates and how it uses vacuum, if we're measuring vacuum in a receiver, at the start of cleaning, the actual 401 valve shuts off and we hold vacuum in the receiver steady. Then we start teat cleaning. So you will not see any action for the teat cleaner in the receiver. As the 401 valves open, the teat cleaner is still cleaning itself just as the VMS goes to start attaching. And we'll see the start of attachment point and the vacuum is slightly higher. After that point, we see the operating vacuum drop in the receiver down to normal operating, and milking starts to happen. And we can see the vacuum in a single unit will operate really consistently. And then once we see teat cups start to come off, we're going to use vacuum to flush and keep all the milk. And then we'll continue milking. So you see that at the yellow point, we see cup removal and vacuum sweeps. And then as we get towards the end of milking, all cups will sweep and flush at the same time, but that's when no milk is milking is happening. So when we actually identify the exact point of when milking is occurring, the receiver vacuum in a single unit, single vacuum system VMS is between 12.9 and 13.4 in this situation. So we had 0.5 of vacuum fluctuation, which would meet the guidelines for CMS. So when we were looking at some of these things, we looked at what the dealers have done. So I took some receiver vacuums for a four-unit barn with a single vacuum system, and during both of these robots were milking at this point, and you can see how the vacuum fluctuation occurs when we have teat cleaners coming on the other robots using vacuum. So is this as good as an individual vacuum system for VMS? And do we think this is good for the cow? For me, I don't think it is, and I think we can be doing better. But I also wanted to show that when we involve the tech team, we actually have much more stable vacuum. So this is actually from Mason-Dixon Farms. So what we can see here is that the vacuum is stable, and between you see where the vacuum drops to zero is actually when the 401 valves are shut. So you can see when cows are milking and when we're teat cleaning at these individual robots. And you can see the vacuum is relatively stable. So when I break that out and I look at that individually, the receiver vacuum on these DeLaval reviewed solutions were pretty good. We were at receiver vacuum of 0.9 vacuum fluctuations on a 20 unit system. But to me, that's still not what we can do with CMS. So just to recap the old designs, right? And we have many people being very successful with this. So I'm not sure we need to make too many improvements to existing facilities, but we could get vacuum volume fluctuation of better than 0.9 and receiver vacuum fluctuation of less than 1.1 inches of fluctuation. And these good performing systems, I did not find any of the systems where the vacuum pumps were on one side of the barn, and we had two VMS rooms either side of a center drive-through barn. So I know there's quite a number of these installed out there where we have 4 or 6 robots, 3 on each side of a freestall barn, with the vacuum pump pipes running to the middle of the barn and then back out to the VMS rooms. These facilities did not end up testing very well at all. So based on the new design recommendations that we came up with, working with Derek's team, with Zach and Ryan and Nate, um, there's a couple of key things we want to bring up. That installations with 2 or less VMS need to be designed with individual vacuum systems. It actually is lower cost to do that. Then when we move to 3 VMS, it's about the same cost to run an LVP 3000 or 3 DVP 800s. And a lot of it will depend on barn design. So as I said, there will be no more designs with a single vacuum pump on one side of the barn with VMS rooms on the outside of a center drive. And this is driven by the fact that the next point, where the vacuum system pipe should not exceed 65 meters or 210 feet of tubing from the vacuum pump connection to the connection of the furthest VMS to the CIV tank. And just to show you the size and scope of what that means is that actually TDI will conform to this measurement. So it's not that we can't do big facilities, it's just that we need to be more limited on how that happens. So then the fourth and final point is that from now on, we need to have VRS and VRM valves as the mechanical regulators. The reason for this is that I know they're more expensive than Sentinels and other third-party regulators out there that the dealerships prefer to use, but a VRS can be set within 1/10 of an inch of vacuum of the VSD and not have an effect of making the VSD drive oscillate. The next point is that when we set these up, and I want to let you know that we're going to run a minimum of 25 to 30 hertz, so half speed on the vacuum pump. And that is key of why that regulator has to be set at just above the set point. So I know that a lot of dairymen will complain if they buy a variable frequency drive and then when we run the motor at half speed. But there's a couple of points for running this at half speed. Number one, when we have teat cleaners turn on, we have an effective reserve that we can use and that the motor can then accelerate from a faster point. It's much easier to go from 60 to 70 miles an hour than it is to go from 0 to 10. And then the other part of this is that the motor will stay cooler and we will get longer life out of the low vacuum pumps. And then the last point I want to make is that the vacuum system should be designed between 6 to 8, maybe 10 VMSs, basically 2 pens or equal to 1 large herd milk transport. Vacuum systems can't be designed where systems can be milking and cleaning at the same time. The demand on vacuum for cleaning is much more significant than milking, and it has an effect on the robots that are milking. Another point is, as we move forward, VMS V300 and VMS Classics should not be on the same vacuum system. The reason for this is that the milk path changes and all the good benefits we get from V300 mean that the actual vacuum that the cow feels in the short milk tube is significantly different. So it's approximately can be up to an inch worth of vacuum difference that the cow feels. So when we're trying to set a vacuum system for liners and operation and what a cow feels, we just need to be mindful of that. So the other part of this is that the vacuum pumps need to be as close to the center of the system and not off to one side. Again, we don't want to exceed the 65 meters or 210 feet. And the other part of having smaller groups is that some of the work that I've done is that VMS really allows cows to exhibit milking speed. And those fast milking cows can really exploit themselves in a VMS system. So you have cows with so some of my thought going forward is we may, to get better performance out of robots, want to group cows on milking speed so that we can change vacuum and set vacuum systems for those cows individually. So CQT. So what do you need to make sure everything's right in CQT? So I think that Mui and Doug did a fantastic job on Monday on laying this out. So I'm not going to not view this too much, but you need to make sure that the length of pipe is correct, and the layout of the vacuum piping. So if you get that correct, then
Muted. Muted.
seems like I'm getting muted all the time. So I'm sorry about that. So yeah, if you get the correct length of pipe, then CQT will correctly size the pipe, either 4-inch or 8-inch. And then from April 7th, basically the vacuum requirements that are in CQT are this, that 3 to 4 VMS we will automatically put an LVP 3000 in. 5 to 7, it will be either 1 4500 or 2 3000s. And then for 7 up to 12, we either have 6000 or 2 4500s. And really, we designed this so that there can be a backup, so it still fits. So I did want to revisit the slide from Monday that Doug gave us, and he did talk about CQT logistic calculations. He talked about 650 and 610. We need to, this was old data that needs to be removed. So please don't review or use the 650 or 610 numbers. They were for classics a long time ago, and especially with V300s, we need more vacuum to wash a V300. The FRV valve is set higher than a classic, so we actually need more vacuum. So again, I just wanted to review that those, if you just let CQT pick those vacuum pumps, then you should be all set. And just be mindful that if the dealer replaces them with smaller pumps, an LVP 2000 is not going to be good enough to run 3 B300s. So just reviewing the lines, and this is something that you've seen. So we will have a loop line. We will have a CIV, FRV valves per VMS. Some of the transfer lines are going to be 110 millimeter, and then basically to get enough reserve close to the robots, then we're going to have the 200 millimeter pipes. And then just as we reviewed on Monday, the connections. So what we're going to look at is that you have the connectors for the valves. You can actually add and should add an extra T connector between VMSs. What we're going to need is to have a direct line of sight for each VMS to the vacuum pump to get the reserve and access to the vacuum, and be sure that a neighboring VMS does not starve another one for vacuum. So there's some other items that have been added recently. So we need to remember that we need enough room in the VMS, and I think that's room above the VMS so that we can put in these pipes and components. Also, there's drainage kits now that have been added for the LVPs. So basically, it only works with multiple pump systems. So when they cycle on and off, and it takes when the vacuum turns off on the pump, then it allows the drain to operate. If you do not have this, there's also a automatic low-level J. So these, as you can see, the picture in the top right-hand corner of the low-level drain. Basically, these low-level drains need to be on vacuum pumps, that single vacuum pump systems, and then also these need to operate at every low point in the single vacuum system. Just allows all the water that it can get into the vacuum line to be drained. And just so you know, especially with V300, this is very important. The V300 was designed to allow much more water to go through the vacuum system to the CIV tank for cleaning, to help with some of the cleaning issues that we experience from time to time with the Classic, and just to be more robust. So each one of those items is available in CQT. I'm sorry at this point there isn't just a group part for this. So when we look at what we've done and where we've moved, we have some example layouts here. So this is a 4-pod system where we had one LVP 3000 running out, and you see that there's an 8-inch loop above the robots, which the robots tap into, and there's a T-piece in the middle of that loop to feed the vacuum, so that there's access for every robot to the vacuum pump or passage of air. And I did just want to show you this, just to show you the scope of size, even though it'd be pretty uncommon unless we change the way we move milk. But we can manage to have 12 robots. Stephanie, what do you want me to show you with the mouse? Okay, so going back, there's a T-piece right here. Hopefully, can you see that now? So it comes into a T-piece here. So again, with the 12-unit barn, we have 2 lines that run out, and the reason we have 2 lines run out is so that we have more capacity of air, and we do not see a vacuum drop from the vacuum pumps to the systems. So again, we have air coming in and teeing into the loops at separate places, so we can get access of air from direct line of sight back from the VMS to the vacuum pumps. But more commonly, what we'll see now is more a 6-system barns, so similar to this, but where we can move the vacuum pumps closer to with the equipment room and have systems set up like this. So we have one line feeding in here, and we have cross pieces that run across the barn and then out to the loop that goes around. And then we have a 6-robot single solution. So looking very similar. So the vacuum pumps here deliver the pipe right into the middle of the system. And then we have the loop and the cross pieces. And I know these are all virtual drawings, but with thanks to Mike Moore and his team, this is a picture of what's being done at Long's Peak. So this is a true to life vacuum system. So here we have the vacuum line coming in and feeding the center of the system. You can't really make out here, but we have the VRS here with the VRM sat on top here. So this is how the new systems will be designed. So what were the results? So what we looked at with that 4-unit barn with the LVP 3000 is that we got the receiver vacuum to exactly match the loop vacuum. And then once we did that, I measured the loop vacuum over 20 minutes, and we got vacuum stability in the loop to be 0.6 inches. So this meets the NMC guidelines and recommendations for CMS. It also is equal to the single vacuum pump for VMS that we have on individual systems. So I think realistically, just to recap that, a centralized vacuum system can succeed to provide equal vacuum stability to one vacuum pump per system, and it's lower maintenance costs and all the other benefits that you've come to expect from it. So as of right now, I'm going to open it up and see with 44 people if this can work. So I'll open it up and see if we have any questions. If not, then I'm going to have people type questions. The floor is open.
Hello, Steve.
Yes.
Hey, this is Todd. How you doing, man?
Good. How about you, Todd?
Oh man, I'm so good at social distancing. I might do this for a living. I had to close my door. A couple quick questions, okay?
Yep.
First of all, I really appreciate what you guys have done on this, because vacuum fluctuation in some of these VMSs is scary. Did any of these tests go over with smart pulsation?
So basically, if the smart pulsation was turned on when we were testing them, yes, no, but I didn't see any difference in vacuum stability where the smart pulsation was turned on or off.
Okay, I wondered if that wouldn't be the case. Okay, so the next question is, why wouldn't we, and I've thought about this on conventional milking too, why wouldn't you just take all of our vacuum lines and go to 12 inches? Because that would give us more vacuum reserve at the point of contact. Doesn't raise that much cost at install. And would that solve the stealing problem that you're worried about with the vacuum earlier on with the different units?
So there's thank you, Todd, for the question. So there's a couple of things we need to be mindful about, especially in this situation, is that we need to make sure that while we have sufficient reserve or capacity at point of source, we also get enough air movement to signal to the VSD that we need more vacuum. So
Okay.
so what I've seen, and actually the actual slide with the really big fluctuation was on really big lines with the with the sensor not seeing enough change.
Yeah. Well, I'm thinking on our decks, if we had our sensors different places, we could do a better job on that. But I understand what you're saying. I'm just thinking that the 12-inch line would allow some junk to get in the line, and we could clean that out every 6 months and still keep things going. So, but I'll go with your because you looked at it. So. Did I lose you?
No. Yeah, no, thank you, Todd, for those questions. Don Meyer has asked a question in the chat. Is the 210 feet to the point where it enters the loop? Yeah, so the measurement is from the exit to the vacuum pump. So if I look at it, it's from here to where the robot will grab air, because typically these distances here are pretty similar. Thank you, Don. Is there any other questions?
Just a quick one. And I do like the individual vacuum pump for VMS. Have you done the cost comparison on bigger and bigger barns?
Yes. So Todd, we've looked at the cost, and basically the break-even cost of individual is right at three VMSs. So at 3 VMSs, it's about an equal cost to put in an LVP and single vacuum system or 3 DVP 800s.
Yeah, but I guess my question really was, as we look at these really big barns, what is our maintenance, et cetera? Because I think basically our maintenance is better as far as long-term costs from a dealer perspective. I mean, talking labor, et cetera, to service individual pumps on a schedule rather than big pumps with some opportunity for failure.
So
I totally disagree with that, Todd. It costs about $75 a month to maintain and oil a DVP 800. They're incredibly expensive. If you put one in ASQ, it's $75 a month.
Okay, well,
$5 worth of oil and $50 worth of parts.
Okay. Hey, thank you. That's what I was looking for as far as some information to kind of sell it. So appreciate it.
Thank you, Don. And then also a comment from Derek. A lot of the driver of getting away from DVPs is the amount of oil, and those people that sold conventional, and when we moved from oil to load pumps, one of the sales tactics was to talk about the lack of oil and the risk, lowering the risk of slipping and falling in the equipment room with oil on the floor. And so dealers and farmers don't want to deal with that also.
Okay.
Yeah, Christian, I will email this deck out to everybody at the end. Is there any more questions?
Could you repeat those numbers? I think it was Dawn said.
So Don said it was $75 a month to maintenance cost on a DVP 800.
So Eric, that's from ASQ. If you plug a DVP 800 in and you follow the scheduled maintenance that's in there, it's going to be about $25 worth of oil and $50 worth of parts on a monthly basis at standard DeLaval LLP.
So I guess the question is, and I'm sure they're working on it, is getting a LVP for those operations.
We looked at it a long time ago, Todd. Basically, that we don't use enough vacuum to run it fast enough to keep the pump from blowing up at low speeds during milking, and then we need a lot of vacuum during T-cleaning and system cleaning. So the LVP does not work well, that application.
Appreciate that, Derek, but if we go to a 12-inch line and put more units on there, I think we're okay. But I'm not here to redesign. I appreciate all this, what's being done, so I'm good. So
Yeah, Todd, on a single pump system, they're typically closed with just the 2-inch line that joins.
well, we can discuss this sometime because we're social distancing offline. But if we ever see each other again over a beer, but we'll figure that out.
Yep.
But the challenge with 12-inch lines is a lot of times you don't have the space for it. And by the time you get your bends and elbows and everything else in there, you really limit yourself as far as, you know, the space you've got to work with. So
Yeah.
I think eight's going to be plenty big enough on these things.
Yeah, you're right, Kirk. Exactly. But I think in new installs, we have to start looking at how we, you know, have enough vacuum reserve at the end of the line to handle everything we want to do. So that's where I'm coming from.
And Todd, that's what we did with this. So the 8-inch line is sufficient to manage this, and as you saw from the graphs, we can maintain vacuum fluctuation lower than 6/10 with 6 or 8-inch lines as necessary. So I do think, yeah, let's take that side of the discussion offline. Does anyone else have any other questions?
One quick question. It was mentioned for all the right reasons that classics and 300s shouldn't be merged on the same looped line. It could be that with some expansions, some existing classic installs, I guess it's case by case, whether it's better to continue with single pumps per unit, or I guess you could reconfigure the robots if there were 3 classics, 3 300s, such that you could have a loop for classics and a separate loop for 300s, right?
Yes, thank you, Mark. Yeah, that would be the case. It would be on a case by case what the barn design would be, but yeah, if you could put, if you had 3 and 3 and the layout was such that would allow, yeah, you could have a single vacuum system for the 3 classics and a single vacuum system for the 3 V300s. Does that answer your question, Mark?
100%.
Are there any
I have a
more?
question, Steve.
Yes.
Jaya from Canada. Would it be possible to have a session for my team?
Yes, absolutely. We can do that.
Okay, thank you.
And I guess to be clear for everyone, this got fairly technical, but we were going to work with Steve to develop or tweak it a little bit specifically for installers and the technical trainings as well, and add this to V300 training.
Sure. Okay.
Great idea there.
Okay, if there final shout for questions, I want to just be mindful of everyone's time here this morning. So last question. If not, hey, I would like to thank everyone for taking time out of the morning to be here today. And if you have any questions, concerns, please don't hesitate to reach out to me or any of the tech team. We've done this in collaboration. And one last shout out, I want to thank Keith for all the renderings he did for my presentation. I really appreciate all the hard work that he did. Well, thank you everyone, and goodbye.